So today we will going to dealing with RSA algorithm, steps to solve RSA algorithm. So in that first step, first we need to choose two large prime numbers P and Q. For example, P will be 11 and Q will be 7, where 11 and 7 will be my prime number. In second step, we are going to calculate n is equals to P into Q. So suppose my P was 11 and my Q was 7. So 11 into 7 will going to become 77. So my value of n will be 77. In third step, we are going to calculate the phi of n. Phi of n is equals to p minus 1 into q minus 1. Whatever the number we are going to take as a prime number p, and whatever the number we are going to q, we will going to minus it and we are going to multiply, we are going to get a phi of n. Now we are going to select an integer e such that integer e can be any prime number such a way that the GCD of those two numbers, whatever the number we are going to get in phi of n, comma, whatever the number, the prime number which you guys will going to take e, the GCD of those two numbers phi of n comma e should be equals to 1. So the prime number what we are going to take e should be in such a way that the GCD of phi of n comma e should be equals to 1. Now we are going to calculate d. D is equals to E inverse mod phi of n. So here in RSA we will going to, as we guys know, we will going to encrypt and we will going to decrypt. Here C we will going to use for a ciphertext. So in order to find out my ciphertext, C is equals to message will be given raised to the power of E, what we have taken here, E into mod n, which we will going to calculate in step 2. We will going to get an ciphertext. So in order to decrypt this, if we decrypt that, if we decrypt, we are going to get a original message m. So m is equals to ciphertext, what we are going to get here, to the raised to the power d mod n. See, as an example, we are going to solve one problem. See, in my example, they have given it as message equals to 2 and my prime p is equals to 11. This is a prime number, and q is 7, which is of a prime number. So here e can be any number. Here I have taken e as my 37. So in such a way that this 37 and the phi of n, what we are going to get is 60 and 37. The GCD of those two numbers 60 and 37 should be equals to 1. So in my step 1, n is equals to p into q. My p value is 11, my q value is 7, hence 11 into 7 will be 77. In my second step, phi of n equals to p minus 1 into q minus 1. So p is 11 minus 1 into q is 7 minus 1, 11. So 10 into 6, 60. So the GCD of these two numbers, whatever the number we are going to take it as e, the GCD of those two numbers should be equals to 1. In my third step, we are going to find out my d value. D is equals to E inverse mod n. Me E, I have taken it as 37 inverse mod 77. So here we are going to find out phi of 77 minus 1 mod n using inverse Euler's, which we have studied in module 1. So refer your previous class notes. You guys will going to get how to find out this inverse using Euler's. So phi of 77 is my 60 minus 1 mod 77. So this solution which I have explained in module 1, 37 raised to power 59. If you simplify this, we will going to get my d equals to 13. So if you have any doubt, you can contact me using WhatsApp. So C equals to m raised to the power e mod n. So my message, the initial message was 2. So I am going to take it as 2 raised to the power of e value I have taken it as 37 mod 77. So this 37 can be splitted into 2 power 20 into 2 power 17. 20 plus 17 will going to give 37 mod 77. 2 power 20 is 67. You guys can check it out. And 2 power 17 into 18, we will going to get it as an 18 if you do with mod 77. Hence my ciphertext will going to become 51. So message, so in order to decrypt, m is equals to c power d mod n. My c, what we have got is 51, and d, what we have got here is 13. So c power d is 51 raised to the power of 13 mod 77. So 13 can be written it as 51 to the raised to the power of 5 into 2. 5 2s are 10 and remaining is 3. So 5 2s are 10, remaining is 3, hence 51 to the power 3. So 10 plus 3 will going to become 13 mod 77. So if you simplify 51 and raised to the power of 5 mod 77 will going to get 32 and raised to the power of 2 will going to keep it as it is into 51 cube. So if we simplify, we will going to get the original message. Hence this is an example problem what we have been solved. And now we are going to see the performance of RSA. So in this performance of RSA, we will going to calculate the time complexity for encryption as well as for decryption. Encryption says that encryption and decryption require repeated multiplication modulo n of b bits numbers. As we have seen in previous example, we will going to repeat the number of multiplication signs. Hence encryption involves constant number of modulo n multiplication. Hence the time complexity is O, capital O, b square. So multiplication of 2 b bit. So decryption involves raising a b bit numbers to the power d, that is d times the multiplication. Hence the time complexity is capital O n b square, where n is hundreds of digits extra digits what we are going to append. Thank you guys.